This is an addendum to my other video where I showed why the range of your electric car may be much worse than advertised. If you've not yet seen that video, you may want to watch it first. In this video, I will show you how I derived an equation for the air conditioner range reduction coefficient, which I call CAC. From searching the internet, I found that air conditioner use in an electric car can reduce your range by 30% when on the highway and 50% for city driving. The way I'm using the coefficient is to multiply it with the advertised range to get the actual range. When used this way, we have a value of 0.7 for the 30% reduction when driving on the highway. As I explained in the other video, the power needed to run the air conditioner is a constant and does not depend on how fast you're going. It is due to the solar energy entering your car through the windows. The air conditioner is then draining your battery at a constant rate. The faster you go, the sooner you get where you're going, and less energy is used to run the air conditioner. This is why CAC goes to 1 as you go faster and faster, and also goes to 0 when you aren't moving at all. This plot shows 3 different possible curves for CAC. Now I will show you how I came up with the equation for these curves. First, let me introduce some variables, E, P, V, D, and T. Using the simple relation distance equals velocity in time, we get this equation. We solve for T and we get this equation. The energy needed to run the air conditioner is power times time. And we can replace T with d over v to get this equation. The force of the aerodynamic drag is A times v squared, where A is a constant to be determined. The energy needed due to drag is the force of drag times the distance traveled. There are other forces like rolling friction which go with v, not v squared. We will lump these into one equation, E other equals b times v times d. B is another constant to be determined. From a Tesla report, it looks like E drag equals E other when V is around 50 miles an hour. From this, we can find that B is equal to A times 50 miles an hour. Now we can add these up to find the total energy needed. Substituting B equals A times 50 miles per hour, we get this. When the air conditioner is turned off, PAC is 0. We can solve for D, the distance traveled, with and without the air conditioner running. Note that CAC is equal to DAC over D no AC. This is the multiplier for reducing your range due to using the air conditioner. Now we can get a formula for CAC that varies with V. Doing simple algebra, we get this. To make things easier, we will define Q equals the cube root of PAC over A. We are combining 2 unknowns into 1. The reason for the Q is so Q will have the units of miles per hour. Using this substitution, we get this. I will call this equation number 1. Now, solving for Q, we will get this, which I call equation 2. Using equation 2, we find Q for different values of CAC when V equals 65 miles an hour. Putting these 3 values of Q into equation 1, we can then generate this plot. Notice that at V equals 65 miles an hour, these 3 curves have the value of 0.75, 0.85, and 0.95. I found on the internet that the range reduction is 30% for the highway and 50% in the city, and that would be approximately the lower curve. The other curve would be what you would get when it is cloudy and you're not running the air conditioner as much.